Okay, so far with the periodic table, we talked about atomic number. Atomic number, once again, is how many protons that you have for your element. And then we talked about the name and symbol, right? So in this case here, we're looking at this element here. This is telling me the symbol Cl, the protons. It has 17 protons, and the name of this is chlorine, right? But what's this number here? 35.45. What is this number? Well, that is the atomic mass. Okay, so the atomic mass is basically the average mass. Okay, so it's the average mass of the element. So in this case, 35.45 is the average mass. Now with this average mass, what's all composed of that? Protons and neutrons. All right, so this is the average mass for this element, 35.45. And once again, this average mass, protons and neutrons. Now, the unit for atomic mass is AMU, which is this, we call this atomic mass units. Okay, so that's what that is. All right. Now, usually you're going to find your atomic mass always below the symbol in most periodic tables. Okay. Now, one thing that we want to pay attention to though is that our atomic mass, once again, the atomic mass, the average mass of the element, it's the average mass of the element. Average mass of the element. So the atomic mass is the average mass of all of the isotopes of that element, right? So because it's the average mass of the isotopes that compose the elements according to the natural abundance of each isotope. Okay, so basically, this is letting me know, right, that the average mass for chlorine is 35.45. And this is based on all of our isotopes. So remember, everybody, an element, all right, most elements are going to have an isotope, okay? And remember, if you remember isotopes, isotopes have the same amount of protons, but a different amount of neutrons. So usually, right, the way that people find the average atomic weight of an element, right, this number here is with this formula. All right, so you're going to take the exact weight of isotope number 1, multiply that by the abundance of isotope number 1. Okay, and then, right, we do that same exact thing here, the exact weight of isotope number 1 times the abundance of isotope. So we're going to do this exact same thing for isotope number 2. I got 4 here, but 2. So isotope number 2, right, we're going to have that exact weight, because remember, right, the weights are probably going to be different, right, because they're going to have different amount of neutrons. Okay, so we understand when we looked at the examples before, all of those mass numbers were different because they have different amount of neutrons. That's impacting the mass number here, right, which we understand now is protons and neutrons. Now, isotope number 2 has its exact weight times that abundance of isotope 2. Okay, and when we add both these things together, right, this is how we get our average atomic weight of our element. In this case, this is how we're actually getting 35.45. So please do not get this number confused. This 35.45 is the average mass of all of the isotopes for chlorine. So this just isn't one thing, right? This is all of the isotopes of chlorine. Let's look at chlorine. So chlorine has two isotopes. In this case, the first isotope, the exact weight of isotope number 1 is 34.97. So notice, right, it's not actually 35.45. All right, it's a little bit less than. Okay. Now, isotope number 1, right, isotope 34, right, for this is more naturally abundant. All right, so it's around 75%. So in this case, the abundance of the isotope, we're multiplying that by the exact weight. So of course, we're going to convert that percentage to decimal, and we get 0.7577. Okay, so this is what we're doing in this first step here. Now, we're going to add that with our isotope number 2. So isotope number 2, right, it's a little less abundant. It's around 24%. Okay, so we represent that percentage as a decimal. And then notice, right, isotope number 2 is actually a little bit, bigger than isotope number 1 at 36.97 AMU. Okay, so we're doing the exact same thing, taking the abundance and multiplying by the exact weight. Now, once we have both of our isotopes right in this formula, we just add them together. And what we find out, right, is that the average atomic weight of this element is 35.45 when you add both of our isotopes together. So this 35.45 represents both chlorine isotopes. And that's with all periodic elements, okay? That's with all the elements, okay? So if you see this average mass, that average mass is a mass for all the isotopes, just not one, okay? Not two, but all of them. What is the average mass of carbon? What's the average mass of carbon? So carbon, if you did not know, has 3 isotopes. We got carbon 12, carbon 13, and carbon 14. Okay, so carbon 12 is the most abundant isotope on this world at 98.89%. Carbon 13 is pretty rare at 1.11%. And then carbon 14, that's super rare. It's so rare that it's not even a percentage for it. So you can really ignore it, to be honest. All right. So what's the average mass of carbon? What's the average mass? So we're trying to figure out, right, this number here. That's what we're trying to figure out. So let's try to figure this out. All right. Right now, if you want to, feel free to pause me. Okay. And try to do this on your own. If not, let's get to it. Got it all lined out for you here. So if we're trying to find the average mass, that's what we're trying to find. We're going to have to use this equation. The exact weight of isotope number 1 times the abundance of isotope number 1. So in this case, carbon 12, right? We know the exact weight is going to be 12. It told me it, right? So we got 12 AMU here. And the abundance is 98.89%. Okay, so in this case, I'm just going to convert that to a decimal. That's how I get this 0.9889 here. So I'm good with my first isotope. Second isotope, carbon 13. So carbon 13, right, is 13.0034. You could just put 13. You could just put 13. I just added a couple extra numbers being fancy to let everybody know. Put 13. That's perfectly fine. 13 AMU. And then its abundance is 1.11%. So I just converted that percentage to decimal here, right? And that's 0.0111, okay? So when we add, right, these two isotopes together, right, once we multiply this by this and this by this, we add those together and we get 12.01 AMU as my final average mass of my carbon. So we're looking at another one. All right, so this time is asking about nitrogen. Nitrogen is made up of 2 isotopes, nitrogen 14 and 15. Okay. So given that nitrogen's atomic weight, all right, is 14.007, what is the percent abundance of each isotope? And here's a hint. Nitrogen 14 is more abundant than nitrogen 15. Okay, so this is going to be more abundant. Now, this one, what y'all have to do for this one? Okay, so it's not as tricky as you think, right? Because we got our formula here. This is what we always have to do to find the abundance. We just have to do some algebra, right, to figure that out. So let's look at this one. All right. So far I know I got 2 isotopes, 14 and 15. So I already know the exact weight of both of those. And then I actually know the average mass is going to be 14.007. The only thing I don't know is the percent abundance for both of these. Well, Dr. J, what we about to do? Well, we about to do some algebra. All right, we about to do some algebra in here. So we have 14x plus 15 minus 1x equals 14.007, right? And just to explain this one more time, we're literally following our equation here. The exact weight of isotope number 1 is 14. We do not know the abundance of isotope 1, so this is the reason why we have a variable of x plus the exact weight of isotope 2, 15, and then this is a key hint. Nitrogen 14 is more abundant than nitrogen 15, and because of this, we have to set up this problem to where, right, it's going to be 1 minus x. It's 1 minus x because this is going to be more nitrogen 14 than 15. In this case, since we only have 2 of these, right, whatever's left over will be going to nitrogen 15. And we're going to equal that to what's given, 14.007. So like I said, y'all, this is algebra. We're really about to get into this algebra here. So definitely feel free to refresh on algebra. If you guys want me to cover some basic algebra stuff, I can. Just let me know. I might know that everybody has different math skills. So let's get to this here. So right now, let's talk about this step here. What I did here is I just distribute, right? I multiply my 14x together to get 14x. That's what we see here. And then I multiply my 15 to 15 times 1, right? Then 15 times negative x. Okay, so this is what we see here when we do 15 times 1 is 15. And then 15 times negative x is negative 15x. This is all that we did here, everybody. We just multiplied. All right, nod your head if you with me. Cool. All right, now we're still just carrying over to 14.007. Now, what do we have to do from here? What we have to do here is we must isolate the variable. So let's isolate this variable. How exactly are we going to do that? Well, you can do this in a couple different ways. You can either combine our like terms here, right? And we're going to get negative x. And then you have to add your 15 over here, right? In this case, you're going to get a positive number. Okay, you can do that. Or you can add your 15x over here. And then subtract your negative 14x over here. So now you have a positive x. And then you subtract your 14.007 to 15. Okay. If you guys specifically want to see the math and you guys specifically want me just to show it out, let me know in the comments. I can do that. But I already got it solved. All right. So x equals 15 minus 14.007. So this is what we did here, right? So basically, right, the way I went about it, I wanted my x to be positive. So I added my 15x, subtracted my 14x, right? And now I got my x isolated on this side. However, I want to get this isolated, so I need to subtract my 14 by my 15 over here. So in order to get this isolated by itself, this is what we have here. Okay, so my x is by itself, and then we have 15 minus 14.007. Do the math, that's going to be 0.993. Okay, so my x, right, is 0.993. So this is letting me know, right, that my 14 is 99% abundant. What do I do to figure out my abundance of 15? Subtract it from the 1x, which we did here. So 1 minus x, which is 0.993, is going to give me 0.007. All right, so we found out that this abundance is for our 15, which is less than. So it makes sense, right? All right, we're going to do a couple more problems. If you want to see more problems like this, just let me know in the comments. If you want to see more problems about natural abundance, let me know in the comments, please.